Hello, everyone. It's Bill Younger again, and I'm here to help you learn how to use Kepler's third law, specifically showing you how to use it for if you have a period of an orbit and want to calculate the semi-major axis, or if you have a semi-major axis and want to calculate the orbit. And I'm also going to include a little bit about how you can use your scientific calculator to do this with just one new button. I'm going to allude to the ways you can use other buttons in case you're a little more calculator savvy, but generally this is just to help you understand how to use Kepler's third law. Now, our Kepler's third law might use different symbols, but it's all the same thing. It's the square of the period is equal to the cube of the semi-major axis, which is in some sense also the same thing as the average distance between the sun and the planet. Now, the version we're using does not include what Newton derived, and hence it only works for objects orbiting the sun. So let's get started. Turning on my document cam. So Kepler's third law really relates the periods of the orbits to the semi-major axis of the orbits, and the period of the orbit was found when you square it and actually use it in years. It's equal to the cube of the semi-major axis, assuming you use it in astronomical units. If you have a hard time remembering this, I once heard a book, I think it was maybe Seed's book, saying that you just have to remember where people celebrate on New Year's Eve. They celebrate in Times Square. So you see that the time one, which is measured in years, is the period, and that's squared. So that'll help you remember. So this is the equation, and basically what he did was he tried various versions of plotting the period versus a semi-major axis and kept getting crooked lines, curves, and stuff like that. But once he finally settled on graphing a p squared and an a cubed, he got the planet data that he knew of all lying on one straight line. And in fact, the neat thing about this is it's such a general rule that any new planets we would have found would have fit that same line. So let's get started. First thing, let's imagine we have a planet that's been discovered orbiting our sun, and its semi-major axis A in astronomical units is 9 astronomical units. In doing so, I would ask, what is the period of the orbit? So P is equal to question mark. Again, I've already got it in astronomical units, so it works where I don't have to do any multiplying or anything. Of course, if you're taking a more advanced course than the ones I'm teaching, then some books will require you, and some teachers will require you to convert this to kilometers or meters and then put it in a different form of the equation, or some of them will give it to you in kilometers or meters and make you convert it to astronomical units and then put it in this equation. I'm not doing any of that. I'll always give it to you in astronomical units, or I'll give you the period in years. So to do this, what I got to realize is that a cubed in astronomical units is equal to p squared in years. So all I have to do is, according to this formula, is I first got to cube a. So I'm going to say a cubed in astronomical units is equal to 9 cubed. And of course, 9 cubed turns out to be 9 times 9 is 81, and 9 times 81 is 729. So I get 729. And then that's, of course, equal to p squared. But p squared equaling 729 means that p should equal the square root of 729. So this is how you do it just in a typical algebra class. I'm going to show you in a second a way to do it again with just one button. So now I'll say p is equal to the square root 729. And when I take that square root, I end up getting 27. So the answer is p is equal to 27 years. Okay, now how would I do that in my calculator? Well, what I would get you to do is I'd get you to type in a 9, and then your calculator is going to have one of the three buttons. It'll have either this button, which I call a carat key, or it'll have this button, x to the y power, or it'll have this button, y to the x power. Whichever button it has, I want you to type that and then hit a 3. Now, once you've done that, you may or may not have to hit equals. Some calculators will do it automatically. Others will have to require you to hit equals, but it should spit out 729. Now, depending on your calculator, if it's there, you might be able to just start calculating with it. If not, you might have to type it in. So I'm going to leave it as if you have to type it in just in case. So I'll type in now 729. Notice we're at this point, 729 is equal to p squared. So I have to do the opposite of raising something to the 2 power. And the opposite of raising something to the 2 power is technically raising it to the 1/2 power, because when you raise a power to a power, you're multiplying the exponent. So if I multiplied 2 times 1/2, I'd get a 1. That happens to be the same thing as what the square root means. The square root means an exponent of 1/2. So I'm going to do again using just one button. I'll put 729 and I'll hit the caret key, the Y to the X key, or the X to the Y key, and then I'll type in 0.5 because that is the decimal representation of 1/2. Again, I may or may not have to hit equals, but the answer spit out should be 27, and you'll know that you've done it right. Again, if you are better with your calculator, then what you're really doing here is you're doing y to the 3 power, or y, or excuse me, 9 to the 3 power, or 9 cubed, and then you're taking the square root of 729. If you know those buttons on your calculator, by all means use them. Let's try another one where we're actually going to calculate the other way. So let's say I give you that the period of an orbit is 64 years. Again, some instructors might actually require you to convert this to seconds and then use a different form of Kepler's third law, or they might give it to you in months or days or something like that and get you to convert it to years before you can use this version. But in my class, I just have my students given the units that they need. So I know that p squared is equal to a cubed as long as the p is in years and the astronomical unit, the a is in astronomical units. I've been given now that the p is 64 years. So the way I'm going to go about solving that is I'm going to take and calculate p squared, which equals 64 squared. And of course, 64 squared is 4,096. And then I realize that's equal to p squared, which is also equal to a cubed. So I need to do the opposite of cubing a, which is raising it to the 1/3 power, which also means the same thing as taking the cube root. So I'll say a is equal to the cube root of 4,096. 4096 here, in case y'all can't read that. And that, in fact, the square, the cube root of that is 16, because 16 times 16 is 256. 16 times 256 times 16 is 4,096. And that's actually the exact answer. Again, let me show you how we're going to do this with your calculator. But again, I'm going to use just one button, and then I'll allude to what buttons you could use instead. So I want to first type in 64. And then I'm going to use the button that I have, either the caret, the X to the Y, or the Y to the X button. And then I got to square that. So I'm going to put a 2 there. And then again, I may or may not have to hit equals. That depends on your calculator. I may or may not have to retype that in, but I'm going to act like you do. So I'll just type in 4096 like that. And now I've got to raise it to the 1/3 power. So again, I'm going to use our single button that we're learning. And this time I'm raising it to the 1/3 power. And you might not recall this, but 1/3 is 0.3333 going on forever. So as many threes as you can type, the closer you'll come to being more accurate. But if you see 4 digits, do 5. If you see 5 digits, do 6. Something like that would probably be a good rule of thumb. And again, you may or may not have to hit equals, but when you do, you will get ultimately 16. So that's the calculator buttons that you'd have to hit to use to do Kepler's third law in solving for a period. So remember, if you're a little more savvy, all you're really doing is taking 64 and squaring it, and then taking the answer to that and taking the cube root of that, and that'll give you the ultimate answer. So if I give you the period, you're going to square it and then take the cube root. If I give you the semi-major axis, you're going to cube it and take the square root. That's it. I hope that helps you.